right, so first I want to get the lesson started off by showing you guys this picture. So what do you see when you look at this image?
An old woman.
I see a young woman. Young lady.
All right, so we have two different answers. So the moral of the story is that looks can be deceiving, and you can't always judge a book by its cover. The same is true for angles, okay? So whenever you encounter an angle, you have to use rules and methods to figure out what the answer is. You can't just assume. So first we're gonna go over some basic angle language. The first thing is gonna be your vertex. The vertex is important because it shows you how you name your angle. So for instance, in this example, this is gonna be angle B. B is the vertex, which is the center where the two lines connect. Or it could be angle ABC or CBA. So you're always gonna name it by that center vertex, and that's gonna be in the middle. All right, there's a couple different types of angles. So one of the first types is going to be a right angle. So as you see here, because there's the square, you know that it's 90 degrees and it's a right angle. You can't just assume, even if you see an angle that looks like it could be a right angle, it's not. Our next type of angle is going to be an obtuse angle. So an obtuse angle is when it is greater than 90 degrees. So for example, this one is going to be greater than 90 degrees. Let's say that it's 120. Another form is a acute angle. Whenever you hear the word acute, think small or fun size. It's cute, okay? So that first example I showed you guys, that's gonna be acute, less than 90 degrees. All right, next thing. Whenever you see a straight line, or if you hear that there's a straight line in a problem, you can always assume that it's gonna be 190 degrees. If it helps you, you can also, if you want to, draw a horizontal line and then break it into two 90-degree angles to reinforce that it's 180. All right, let's see here. If we have an angle, and let's say we have a line that goes straight down the middle of it, or bisects it, which means cuts it in half, it's going to be safe to assume that this angle is going to be split directly in half, okay? So if this was 120 to start with, and I bisected angle B, what would this angle now be?
60 degrees.
60 degrees. Okay, what about this one?
60 degrees.
Perfect. So these are going to be the same, which means that they're congruent. Okay? If you ever see the word congruent, it also has a symbol. So in this case, angle ABC, well, let's call this a new thing. Let's go with that. So angle ABF would be congruent. This is the symbol for congruent to angle ABC. Okay? So equal sign with a squiggly on top. All right, next thing is parallel lines. So parallel lines are two lines that go on forever and ever and ever, but never touch. Okay, so they look like this. Think of parallel parking. All right, so if you were to come here and put a line through it, that would be called a transversal. Basically, a transversal is any line that cuts two parallel lines. All right, so with parallel lines, if you have a transversal, you can always assume that the angles across from one another are congruent. So these vertical angles that are across from each other are congruent. So this was 30 degrees. What is the measurement of angle C?
30 degrees.
Perfect. Awesome. All right, and then if you continue this pattern, it would actually go down through the transversal. So again, vertical angles are congruent, so A and C would be the same measurement, and so would these two angles. Okay? All right, so now let's look at angle A and B. So forget this part for just a second. If you're looking at this like a straight line, could you figure out what angle B is? If you're just looking at the 30 degrees?
Yes. Yes.
What would angle B be?
150 degrees.
150. And why would it be 150?
Because 180 degrees minus 30 degrees is 150.
Perfect. Good job. That's awesome. All right, last thing is going to be, let's see, perpendicular lines. Running out of room here. Basically, perpendicular lines are kind of what I showed you down here. So if you have a horizontal line bisecting a vertical line, it's going to be perpendicular. And you'll see it, if you ever see it on a test, the symbol is going to be just like that.